Welcome back students. This is Megasham Raju, Engineering College Bikaner, Assistant Professor in Mechanical Department. For the subject Metrology and Measurement, we have come across 3rd, 4th chapters. And now coming to the 5th chapter, Coordinate Measuring Machines, which is a very important topic. Already we have discussed the introduction and what are the different types and where we will be using these coordinate measuring machines. Wherever we required in 3D measurement, where our space of the measurement is like a cuboidal, then we will be using coordinate measuring machines. So what are its potentials we have discussed, and what are the different types of structures like cantilever, bridge, then column, horizontal arm and gantry. Now coming to the modes of operation, it depends upon the type of the construction and degree of the automation. Then the basic modes are like this. The first mode is like manual, the second is semi-automated, and third mode is controlled, computer controlled. In this manual operation of coordinate measuring machine, in which the operator can freely move the probe along the machine in 3 axes to establish some contact for the workpiece. The differences in contact position are the measurements. A semi-automatic machine is provided with an electronic digital display for measurements, as well as some other functions like datum setting, change of sign, conversion of dimension from one unit to another unit. With one electronic button, he can change in the semi-automated. Now coming to the computer control, how CNC machine will be working. In the similar way, the CMM machine will also be work. It is having an versatility, convenience and reliability. Then this computer assistance is utilized for 3 major functions. Firstly, you will be doing some program which directs the probe. So the path of the probe will be initially programmed for the data collection. Secondly, measurement and measurement commands enable comparison of the distance traveled to the standard built-in to machine for the axis. Now we will be doing the comparison with the datum. Then thirdly, computational capability enable processing of data and generation of the required results. These are the process in which CMM has to be used. Now coming to the important part of the CMM machine, which is nothing but a probe. You know, this probe is the main responsibility for the measurement. So it is necessary to study the important parts in it. The probe is a main sensing element in a CMM. Generally the probe is of contact type and contactless are also there. Coming to this contact type, that is, it is in physical contact with the workpiece when the measurements are taken. Contact probes may be either hard probes or soft probes. Hard probes, using of these hard probes is not advisable unless until your workpiece is of having a rough surface, very like the roughness factor is high. So mostly they will be going with the soft probes. However, some CMM are also having the non-contact type, which is nothing but a laser pointer or some light mechanism they will be using in it. Now if you just see this figure, this is the probe mechanism. It will be having a probe head, and this is the probe, and this is the stylus. Stylus is mainly responsible for the measurement of the roughness or waviness of the particular surface texture. So this figure illustrates the main components of the probe assembly. A probe assembly comprises probe head, probe and the stylus. The probe is attached to the machine by means of the probe head and may carry one or more styli. So if it is having more than one probe, we'll be calling it as an styli, plural form of the stylus. Some of the probes are motorized and provide additional flexibility in recording coordinates. So if you are having 2 or 3 more probes, and by using the motor technology you can control the mechanism of the other 2 probes. So the stylus is integral with the hard probes and comes in various shapes such as conical, ball end, as we have seen in the previous lectures, with the stylus mechanism uh, for measurement of an roughness and waviness. We can use the rounded stylus or a elliptical stylus or the conical stylus. As power fed is used to move the probe along different axes, care should be exercised when contact is made with the workpiece to ensure that excessive force is not applied on the probe. So if it is a semi-manual, whatever CMM machine you are using, if it is a semi-manual CMM machine, then you have to take care such a way that you are not applying more pressure over the workpiece, which will result into a wrong measurements of roughness or the waviness over the surface. Excessive contact force may distort either the probe itself or the workpiece, resulting in inaccuracy in the measurement. Use of soft probe mitigates the problem to a large extent. That is the reason I have told you that most of the CMM machines will be using the soft probes. In rare cases they will be using the hard probes. Soft probes make use of electronic technology to ensure application of optimum contact pressure between the probe and the workpiece. So along in stylus there will be some feedback mechanism in which if you are applying more force over that stylus, then there will be some control system. It will indicate that the force there will be some limitation for that whatever force you are exerting. Some measurement situation, for example the inspection of the PCBs, printed circuit boards, required non-contact type probes. So measurement of highly delicate objects such as clay, wax, if we just apply more force over that, there will be some deflection over the workpiece. So for the type of measurements we require contactless type. So mostly they will be using some light technology. Most non-contact probes employ a light beam stylus. The distance from the point of measurement is known as the standoff. So the air gap between the workpiece and the stylus will be calling it as an standoff distance and is normally of 50 mm in measurement. The system provides 200 readings per second, so you can just assume that 200 readings per second we are getting. How accurate it will be for surface with good contrast. So while using this light beam technology, you have to make sure that the contrast means you should not use the dark backgrounds. So if you just use the black color, then there won't be any reflection. So mostly the contrast like and light colors preferred for the workpieces so that the measurement will be accurate or precise. The system has high resolution of the order of 5 into 10 power minus 5 or 5 into 10 power minus 6 mm. So this much of resolution it is having. So you can assume how precise the value whatever you are measuring from these probes will be. So guys, tomorrow I'll be explaining you the functioning, how the CMM machine, like in the previous slide I have explained. Initially coding will be there, then there will be comparison, then according to the result the path will be there. Like that I'll be explaining you with some diagram. Then after that The remaining part of the 5th unit I'll be covering, and in the 6th unit I'll be giving you the PDF. So then we can complete the syllabus. Thank you.